Well, hello everyone. Thank you for joining us. We're very excited to be here. I have a few friends from the C++ team joining us today, and we look forward to answer any of your questions. I do want to go really quickly through a few slides introductory before I introduce the guests. So bear with me. While I'm also trying to use the producer view of Teams, which is a new expert mode for me. So welcome. We will be doing team introduction shortly, but I did want to give you a heads up of how the session is going to go. You can ask your questions in the chat box on the right-hand side. Questions will appear once one of the producers approve them. And then you get to upvote. We will try to pick the most popular questions, and one of the presenters is gonna answer. And anything that we do not get a chance to answer today, we will follow up on Twitter with you, and hopefully I'll have our Twitter handles available soon. So with that, okay, one more reminder, the session will be recorded, so you will have access to it, we will have access to it. There is a code of conduct that you need to be aware of, and there's a bit more detail here, so I'll leave this up for just a few seconds while I try to connect from my other machine where I'll be following the questions that you submit. Hopefully that's going to go well. Okay, that's great, and I can already see a few questions popping in. So with that, I will introduce our guest today. My name's I'll be moderator. My name is Marian Luparu. I am the program manager lead for the C++ team working on Visual Studio, Visual Studio Code, and vcpkg. And today I have with me Bogdan. Do you want to introduce yourself?
Yeah, hi, I'm Bogdan Mihalsia. I'm the engineering manager for what people call IDEs. I have Visual Studio, VS Code, and also I'm working on code spaces.
And I have a question for you, Bogdan. What is your favorite feature in any of the products that you're working on?
Oh, there are so many. It's hard to actually play favorites. I'll pick one that actually it's a cross for find all references. It's something that I love the most. But if you ask me the most important feature, it's IntelliSense for me.
All right, thank you. I'm going to switch it to Russell. Russell, do you want to say hi?
Hi, I'm Russell Hadley. I'm the engineering manager for the C++ backend. Does the code gen. I'm thinking ahead to what Marian's going to ask me just now, which is my favorite feature. And my favorite feature is one that I think is both most important to sort of the product, but also most important to me, which is the iteration build time. Getting the compiler and linker to speed up so that it delivers better sort of like F5 build experiences for developers. Which helps me in my day-to-day and makes me happy too.
Thank you. And our next guest is Uzi. Uzi, tell us a bit about yourself, and don't forget to mention what your favorite feature is.
Okay. Good afternoon, everybody. I apologize for the sound coming from my window outside. I closed the window, but there's the groundskeeper working outside. It shouldn't last more than a few minutes. My name is Ulzi Lufsambat. I'm the engineering manager for the C++ language org, which consists of 4 teams. The MSVC compiler, the front end, not the code generation, which is Russ's territory. Also the C++ libraries, STL, standard template libraries, MFC, ATL, all the libraries that you know. Also static analysis, prefacet checkers, core guidelines checkers, as well as C++ toolset acquisitions and VC package. That's my team. What's my favorite feature? I have a lot of features, obviously. I've been in the team close to 20 years. I generally like features, that make your code simpler, easier to understand, easier to maintain, and most importantly, easier for the compiler to parse. Those are the features that I like. That includes, const export, decal type, auto, and modules. That's coming. There you go. Back to you, Marian.
All right. And I will switch it back to slides because we do have a list of suggestions areas based on the introduction that we wanted to have here up on the screen. And with that, I will try to pick some of the top questions. So the top voted question right now is, what does Project Reunion mean for C++ development on Windows? So for those that haven't been caught up with the announcements at Build from yesterday, Project Reunion is the unification of Win32 and UWP. And they're being brought together into a single package that all developers, whether they're C++ or C# would be able to consume, thus leading to a unification of apps and libraries. So what does it mean for C++ development on Windows? I'll jump in and say that I think it's a very exciting development. It's been almost 10 years in the making, I guess, with UWP coming alive in 2011, I think. So it's really a reunion. And this will allow C++ developers to stay a lot more focused on targeting a single platform when it comes to Windows, rather than having to worry about the subtle differences between UWP and desktop. I think the most exciting thing coming out of this Project Reunion is the WinUI 3 announcements, the availability of XAML to C++ developers on desktop, which used to be the sole place where you could access it is in UWP. Any other thoughts from the speakers on Project Reunion or WinUI?
Not from me.
All right, then we're going to be moving to the next question. And I think I'll pass this one to Bogdan. So what can we expect in the area of IntelliSense support, debugging, robustness, and compilation speeds? And I think you'll want to share this with Russell as well, since compilation speeds came up.
Yeah, so I'll cover IntelliSense. I think the most important thing for us in IntelliSense is basically the next conformance. We're actually making a large investment to have IntelliSense be on parity with our compiler, and also with the cross-platform other compilers, the basically other tool sets that we have, Clang and GCC. And also we're investing heavily in performance. We're trying to actually make the IntelliSense experience as performant as possible. Now, when people call IntelliSense, they are referring to a few aspects. Some of them are ingrained into how we do browsing, how we actually parse the code. All of those are belonging to what we call developer experience and the rich productive editing experience you see in both of our products, Visual Studio and VS Code.
And how about build throughput?
Hi, yeah, we've got some interesting stuff in the pipe for build throughput. Like over time, as you can see, if you follow the VC++ blog, we've put out a number of improvements to help sort of like end-to-end time by improving the linker. That's actually continued as we move forward. In 16.7, we're actually previewing some functionality to improve the incremental linking, essentially make incremental linking apply to more scenarios. And then for 16.8, we have some exciting new changes that we really don't want to talk about yet, but there's more coming. So like over time, we continue to sort of like work with the entire tool chain to sort of make it faster for people to get through their daily loops. One of the things we've noticed, and we've started sort of an initiative to address, is that sort of the tool chain, using the tool chain can be kind of complicated. So we have this tool called Build Insights that we've recently put out, that we've also blogged about, that allows you to take the telemetry events that the tool chain puts out in combination with the Windows telemetry events and actually build up a sort of like holistic view about like what the compiler and the tool chain are doing. So you can get insight into how PCHs are used, how the linker is sort of like linking like many of the third-party libraries you may use. This is a place where you can actually like get insights into your build and speed things up yourself without having to wait for new changes from us as well.
Yeah, and that has been a very exciting development. The visualization that you can build with these tools is amazing. Gives you great insights into where are the bottlenecks for your C++ build. So we'd love to hear from everyone. Go try them today. vcperf, the C++ build insights, and let us know the results that you can have from these insights. All right, the next question is, where do you see C++ going in the next 3 years? And I think this is a very loaded question. It could be about C++, the language. It could be C++, the tooling. It could be C++, the community. I'll interpret C++, the community, and then I'll let the other speakers answer for probably the other interpretations of this question as well. What I've seen in the community is this amazing growth when it comes to the number of C++ conferences that are available out there. The content that is being produced by so many great minds in the C++ community that's being shared, and everybody is learning so fast about how the language is evolving. And I can only see this community grow, and Microsoft will try to do as much as possible to shepherd this community, to make sure that we create the right tools and the right avenues for this content to be available to everybody. What would be some of the other interpretations that you folks have? What do you think, Uzi? How would you interpret this question? Where do you think C++ is going to be going in the next 3 years?
Okay, thank you. So that's a good question. You know, C++ is a language that is rapidly growing. It's kind of it's a jaw-dropping statement to say, but that is true. It's definitely growing fast. We have you know, lots of vendors conforming to the standards. From, you know, I'll give my stance from the language perspective. I think the next 3 years there's going to be focused on finishing the C++ 20 features. Yes, the C++ 20 feet, you know, the standard is done, and a lot of the vendors going to be coming around, you know, implementing and shipping their compilers that conform to it later this year, early next year. But really, the next 3 years is finishing the completion end to end for the experiences for the C++ 20. And here, what I mean is, you know, features like C++ coroutines, modules. These are unique features that spans across multiple C++ standard versions, that requires multiple iterations of the vendor compilers to implement the end-to-end support. Yes, we have the compiler support, or we will have the compiler support, but on top of that, we need to have the library support. We need to create the ecosystem, the tooling ecosystem based on C++ modules and such. So finishing these remaining parts for the C++ 20 would be a good focus from the language perspective in the next 3 years. Also an area of focus would be tooling. C++ is a language that's been around a long time, but unfortunately the tooling aspect is a bit segregated. It's per vendor specific tooling. There's not much unified cross-platform C++ tooling that's universal to all vendors and platforms. So that's an area that's going to be getting a lot of attention and focus in the next 3 years. Okay.
Cool. Thank you, Uzi. Russell, what do you think? Where do you think C++ is going to go in the next 3 years?
So for me, the sort of way I see it, it has a lot to do with sort of like continuing to deliver on our sort of productivity and no overhead approach. Developers should continue to expect to be able to adopt new features in the language and still get high performance, high out of the box quality from our tool chain. People should still be able to use new functionality that Ulzi's team is bringing and still end up with good F5 build times. We really want to deliver it so that the developers feel productive, and as they adopt new features and like move up to new tools, their experience gets better and their productivity is higher.
Wonderful. Bogdan, do you have anything to add?
So actually, I have the answer from my two colleagues. But I will add to that. I think we will head towards also a lot of cross-platform. I think the fact that we'll have to have not only that a great experience by having all the products work seamlessly between all the products. These days, everybody creates applications that actually target multiple platforms. And we'll have to have all the features and all the experience kind of work seamless between them, because developers will switch, and when they switch, they have to find familiar spaces. They don't want to basically have a different experience on every single platform. So I think that will be a major thing. And the other thing that will be important for us as C++ will be how we take advantage of interacting also with other languages. Because developers are polyglots, and the interaction we'll have and the experiences we have while we interact from C++ to the languages will be also key in the next few years.
Wonderful, thank you. And absolutely, I think tooling has a very important role when it comes to C++ modernization. Whichever direction C++ language goes, the tooling will have to keep up and help developers continue understanding and continue writing code with the best productive tools at hand. And I think that's part of our role as Microsoft to handle this. The next question, and because of the votes, they keep jumping up and down, so I'll take the one that is at the top right now. What about MFC? What about MFC, Uzi? Do you wanna give it a try? That's an interesting question, isn't it?
Yes, MFC is very much a product that we support, and we have a team. We have engineers dedicated. We have a team as well, and remote team that their sole reason, work is MFC development. So we very much support it. We definitely fix bugs. If there's any breaking changes or any adjustments we need to make for new features or for new dependencies and such, we will fix them, and we are fixing them.
Yeah, and I'll say the Win32 programming model hasn't changed significantly for the past few years. There's always a lot more that we could implement in MFC, but it is a mature technology, and it's being successfully used by large ASVs. As a company, we are very excited about the direction modern modern UI framework. Direction the modern UI frameworks are going, like with WinUI, and MFC has a good integration story with WinUI through what was the term? The islands. Why am I blanking out on the term? There is a way to do the interop.
Example islands.
Thank you very much, sir. And it will always be a way to evolve those MFC applications and bring more modern constructs into it. All right, we're going to move to the next question that I marked as something we want to answer. And Russell, I think this one may be for you. I'll read it out loud. What are some of the easiest way in C++ and C to make use of multiple CPU cores and vector instructions to parallelize a for loop, where each iteration of the loop is independent?
There's a couple of pieces of this question. I'll try and like split them out. And some of the things are forward-looking that I might say here. So like take it with a grain of salt, and some of these things will refer to the functionality we already have. For vector instructions, when you're doing code gen for vector instructions, that's mostly going to be on one core. Each one of those vector instructions is sort of issued against one core on its own. So the vectorization that we've invested in the compiler, the new AVX2 support, the AVX 512, that will be sort of addressing a single core. For using multiple cores, we have some support for parallel keyword in the OpenMP support we have today, but we're looking at extending our OpenMP support and making the MSVC toolchain stronger at supporting new standards. So that work is something that we're investigating now, and I'm not prepared to sort of like go on record with dates, but I expect to sort of tell people about that functionality going forward. So that'll be another way that's easier. And then if you want to go back to the really old school, is like just get comfortable writing threads. I sort of say that mostly as a joke. It's not as easy to do, obviously, but it's still there. And if you're doing it in C, that's going to be your best bet.
Thank you, Russell. And I lost my question again that I said we're going to answer. Well, thank you for voting. Lots of questions. Let me try to chase it. I'm sorry, I don't see it anymore.
Analyzers.
Oh, yeah. Do you remember what the question was?
Yeah, so the question, I mean, I'm not seeing it on the screen, but I'll just take it from memory. There was a question about static analyzers integration in the IDE, and also relative to our static analysis, and also relative to client ID. So the answer there is yes. Static analysis, it's one of the best way to actually create safety in your code, and we do support both. Fairly recently, we added also a new thing, and in preview in 16.6. If you have the preview channel, you can see what we call hints. It's a very fast way to actually detect very light static analysis like errors that you can quickly fix and patch. And then also in the background, we have what we call regular static analysis based on build that's provided from our compiler. It's deep analysis that actually allows you to find deep issues that we have actually for many of them recommended fixes, and for some of them we will add support. And obviously, we have also client ID for the cross-platform code bases, and we are improving that as well. So our goal is to try to create a very uniform experience so customers can actually benefit from this, because it will help with productivity, and it will help also with the safety, and it will benefit all the code bases around the world, the ones that actually are using our product.
To add on Bogdan's point, which he talked about integrating static code analyzers. We also have prefast MSVC-based static analysis checkers and rules, and we are actively developing. Not only we fixing them and adding more features based on them that gets exposed through the IDE. We're also investing in more checkers and rules, not just the actual checkers, but enhanced framework and infrastructure that supports this. That's based on the MSVC toolset. So you can definitely look for more checkers around C++ code safety, security rules. You know, that would that would help our C++ programmers to write secure code, and as compare that to Rust developers and how Rust is considered to be a good systems programming language, and we want to make sure that C++ developers have the right tools and guards that can write safe C++ programming.
Yeah, and I think I touched on this in the interview I had with Seth a bit earlier. One of the challenges today with running static analysis is that you may get overwhelmed by the large amount of warnings that you may get from all your code base. And something that Visual Studio does is running this static analysis in the background, as Bogdan was saying earlier. Our code analysis, Clang Tidy, or this linters that are new that are running as part of the IntelliSense engine, only for the files that you're actively editing, thus reducing the cognitive load and not having you chase, different warnings across your code base. If you're inside the function that you're editing, and that's where you see a warning, you might be tempted to fix it, not something that it's somewhere randomly, who knows where in your large code base. Cool. Any other thoughts before we go to the other question? All right, going once. I will read the next question. So there are two currently supported compiler stacks, MSBuild plus MSVC and CMake plus Clang. Well, I disagree. Where do you recommend each? And will there be any consolidation in the future? Any takers for that?
I can answer that. Obviously, I think it's a very interesting question. I think it's adding a little bit too strict of a rule because I don't think we have those clear stacks. But what I would say is, like, to me, if you're writing cross-platform code, I think the obvious choice is CMake from kind of a meta build system, and I think that's kind of the we're investing heavily on. The experience we have there is not limiting you only to Clang, so you should be able to use toolsets that actually are important to you for each of the platforms, and that's something that it's available to you. Obviously, MSBuild has been working with MSVC for a long time, but you can actually integrate other tools as well. It's extensible. And we do have actually default implementation for some of them, which allows us to target other platforms. So I would say the easiest way to actually answer the question from the point of view which one to pick and when, I would say if you're writing cross-platform, go with CMake, and that's a clear choice. Now the tool sets and all that, it all depends, because it depends on what you do. If you do IoT, it's one tool set. If you do something else, a different tool set. It's all depending on the target application you're using.
Yeah, and I agree. And I think the goal of Visual Studio is to allow you to switch between as many compiler vendors and switch between as many build systems as you want. It's not strictly those permutations. You can use MSBuild with Clang. You can use CMake with the MSVC compiler, and like Bogdan said, you can use GCC. It all comes together inside Visual Studio. Whether you target Windows, Linux, or Mac OS or other platforms, you can target it from the comfort of a single IDE. I hope that answers it. Any other thoughts before we go to the other questions? So the next question is related to this. So why is cross-platform development limited to Linux and does not allow other platforms where GCC, GDB, SSH are available? For example, FreeBSD, Solaris, AX. So if I were to guess, I think the question is specifically about the Visual Studio support for targeting Linux. What are your thoughts on this, Bogdan?
I think it sounds like that. Alexander actually had a very good question on that. I would say that Visual Studio is very extensible. Like, we do have what we call a default implementation. We added capabilities to Visual Studio that can benefit extenders as well. Adding support for any of these platforms obviously will come. We are working on the ones that actually are very popular right now, and we will probably add support for the ones that actually become higher in popularity as we add support. keep in mind, if it's something that you want to do, there are ways to actually you can extend. Visual Studio is very flexible, including the build system. So it depends on the level of support you want for those platforms. You might be able to achieve, even today with what you have, some flexibility in those platforms.
Thank you. So the next question is, how do you feel about Microsoft recommending recently Rust as a safer alternative to C++ for system application development? How are you thinking of evolving security and safe development practices in Visual C++? And I think Uzi already touched on that. And I'll turn it back to you to kind of do a +1 on that, Uzi. What I'll say is that we are very excited about the progress that Rust language is making, and we've been working closely with our security teams to make sure that the experiment they're running to figure out whether Rust is fitted as a security, as a system application development fully fledged language is going great. And we're also using that as a learning opportunity to see where the C++ language is meant to go.
Yeah. I don't want to repeat myself, but I'll just, enhance what I just said, what I said earlier, which is, we're not just thinking about, looking into adding more checkers, static analysis in code safety. We are definitely and deliberately looking into the gap between, Rust and C++, where the safety, the gaps are for the programmers, and deliberately going after those and in creating checkers based on our CFG graphs, code flow graphs, and writing checkers. And if it turns out that our graphs and ASTs where we that power our checkers do not have sufficient information to be able to do a holistic check for the specific security rules, then we're going even further down into the compiler to make sure that we inject the right the code artifacts to be able to use for these checkers to cater to customers, developers that is feeling the need for the gap between C++ and Rust languages, programming languages.
All right. Thank you, Uzi. So the next question is coming from Brian. Why hasn't the C++ compiler been refactored like the C# compiler to provide compiler as a service? This is a very good question that I think lands between Bogdan and Uzi. Who wants to take the first stab at it?
I'll go first, and I think I've given an answer to a version of this a couple of years ago in one of Channel 9's Steve Carroll's interview. So our code base, the MSVC compiler code base is pretty old. When I say old, I'm not meaning like 5, 10, 15, 20, or 25 years. I'm talking 30 years old. It's very old and it's rigid. We for the longest time we didn't have sufficient abstract way to represent the code to create an AST. But in the past 5-6 years, we have been modernizing the code base to be able to catch up to the C++ 14, 17, and 20 standards. And as part of that, it did require us to refactor parts of it. So, it may not be useful, visible to the users just yet, but behind the scene, we have a wholly refactored compiler code base. We actually have two independent parsers running when you call the MSVC compiler. The old YAC-based compiler parser, as well as a new recursive descent parser running, working together to modernize and to be able to cater to the modern C++ features. More to come later.
Yeah, and I think with code spaces and the compiler really moving their builds in the cloud, that creates some interesting scenarios that maybe the way we're thinking of compiler as a service changes a bit. Bogdan, what do you think?
It's a very good point. I would add to that is when you think about, like, we do have a bunch of services that could definitely benefit from being a service, where the ability to actually be somewhere in the cloud, cached, shared between teams and team members. It will allow to actually not only improve the productivity, but also it will allow the ability to switch between things that actually explore the first time, even if it's actually your first opening of a certain large code base. You can actually get everything pre-parsed, if you want, by the fact that somebody else did it before you. So all these opportunities will be there once you have services that are from the compiler, but it could be also other things like IntelliSense, project system, and so on. These are static analysis. It's yet another thing. So it's just a big feat of imagination that we can actually do, and realize that this is opening a bunch of new frontiers for us. So it's actually very exciting, in my opinion. It's a very good question.
Mm-hmm. That sounds good. I will take the next question then. This is a very specific question. Can one generate a single executable with C# and C++ CLI and native C++ in Visual Studio? I believe the answer to that question is no, but I'll turn it back to the other presenters if they have any thoughts.
I have some thoughts, and it's mostly because you know, some of us actually have worked on .NET in so many years ago. So in .NET Core 3.0, there's actually the ability to package a number of assemblies into a single exe. And I know I've seen somebody's roadmap, like secretly, way long ago, that this kind of functionality has a lot of people asking for it. So I would sort of stay tuned. But there's like a most of the way there solution already in .NET Core. I'd encourage you to look at that. I'm going to ask Marion how to put the link in the chat for the tutorial on this, which I looked up.
Oh, wonderful. I think you can try to make an announcement and everyone should be able to see the link. As always, this is something that we can follow up on Twitter. So you know Russell's handle, it's on the screen over there. Tweet at him. He's going to come back with the link to you. There is a tie between these three questions. So for everyone tuning in, if they can break the tie, that would be great. Okay, the tie has been broken. So the next question is, will the use of Nuget packages be better supported for C++ projects? Now, I have a lot of thoughts about that question, but Uzi, do you wanna jump in?
Actually, I think you should start, and then I want to add something with vcpkg.
Yes, that's what I was going to add as well. So let's all start. No, Nuget is the .NET package manager, and that's the best design that has been designed for. The IDE integration benefits both C++ and .NET projects, and the way it works today, we feel like it's sufficient for satisfying binary distribution. The most problematic things in the C++ community, it seems that they go beyond binary distribution, and it has to do with, when it comes to binary, it's more about binary caching, and really the biggest challenge is building from source and consuming those libraries out there. So that's where vcpkg comes in, and I'm sure Wiz is going to talk about the roadmap for vcpkg. We do not have specific plans to improve the Nuget integration inside Visual Studio. The only thing that we are actively working on, it is a suggestion that we got on the developer community to improve the support for for the integration with package references, specifically for .NET Core. We think that's important. If you're doing a lot of C++ CLI in .NET Core, which is a recent announcement that we did, we do want to make sure that you are able to consume the NuGet packages that are coming from the .NET team that are the official ones. So rather than today having to add those references into the C# projects and finding weird ways to consume them from C++ CLI, we will make that experience easier. For native development, we strongly recommend vcpkg. And Uzi, can you tell us why?
Okay, thank you. I see a bunch of other vcpkg and Conan related questions. So I'll try to just kind of batch them all up here, if possible. As Marion was talking about Nuget for C++ binaries. I mean, to simply put, it does work. It does work, and it's enough for a lot of users. But to simply put, C++ is a unique language compared to the other languages in a way that it really has an unbounded dependencies. When you have a binary, a static library of C++ that has dependencies, it's going to depend on what version of the compiler tools that you use to build, and depending on that, you're going to end up with, even the source doesn't change, the compiler version is going to have some kind of imprint of the binary that's going to be different. What kind of compiler switches have you used? What about the flavors of the library that you built? What about the flavors of the runtime, the library that targets? You put all these together, the number of binaries you need to have for a single source it just goes unbounded, right? And therefore we have a solution, and we've had it for a couple of years, and it's called vcpkg. I know many of you have already seen it. It's an open source cross-platform project that's hosted in GitHub, and we have over 60,000 monthly active users on vcpkg, and it has a catalog of over 1,300 open source libraries that we maintain and guarantee compatibility and support for across 8 different targets, configurations, or triplets, I think it's called, with the latest Visual Studio releases. So this kind of guarantee obviously comes with a cost, and we have a team that works on this on a daily basis. We have a lot of great contributors. We have over 800 unique contributors on vcpkg that help us maintain this. I think there was a question on someone like, what are some pros and cons between Conan and vcpkg? I think there are many, but one of the things would be, vcpkg, we guarantee that over 300 libraries are supported and they work on a daily basis. So that would be one of the big differences. And there is a roadmap. I'm not going to go through the roadmap. At the dev blogs for CPP blog, we have a roadmap. Our program manager Augustine Popa published that goes in details on what we're going to be doing for vcpkg in the next 3 to 6 months. And as you read that, you're going to see a clearer picture of what the things that we are focusing on, which is in reflection of trying to close the gap between Conan and vcpkg in terms of features. Okay.
Thank you, Uzi. So the next question is, are there any plans to add more out-of-the-box C++ refactoring tools for working with legacy code? Bogdan, what do you think?
So this is actually it's an awesome question. When you think refactoring is probably the most important tool to actually allow you to maintain all code bases. And not only that, in order to be productive, you have to have a large spectrum of refactors. And I think in Visual Studio today, default, we have what I would call the most common refactors that people use. enabled, and obviously we are looking into actually improving those refactors as we move forward. And there are a few things that are fundamental refactors that people can think of, but there are also the refactors that are targeted sometimes from things like, for example, the linters that I was talking about, or the static analysis, where we add basically refactors that will target specific problems, so we can actually allow not only bulk editing, but also contextual editing with previews and so on, when it's actually a little bit controversial. What are the choices that the users can make? Because writing a perfect refactor, depending on the complexity and the size of the refactoring, it's important, because we are trying to stay away from actually breaking customers. So the answer to your question is yes, we're actually trying to add as much as we can. We are trying to add also the ability to do bulk refactoring. So those are like things that actually will help.
Yep, and I'm not sure how familiar Anonymous is with our existing refactoring capabilities. I do recommend to check out our blog. The URL is very simple, is aka.ms/cpp, aka.ms/cpp. And you will be able to find some new functionality that we added in this 2019 release, like refactor macro to const expert. You're going to find help with IntelliSense inside templates. There is the new linters that Bogdan was mentioning earlier that have auto fixits for some of those warnings. So there's still already a lot of modernization tools available inside Visual Studio, and they're available not only when you target Windows, but when you target Linux, regardless of the operating system, whether you're using CMake or MS Build. This is the value that Visual Studio can provide. And plus one, what Bogdan was saying, that we're going to continue investing in this. So the next question is, can you please share some information about performance profiling options with respect to CPU cache, especially cache misses? I see this topic is usually less covered than classic profiling options with respect to CPU time or memory usage. To be honest, I don't know what we have specifically for CPU cache in terms of tooling. Feel free to jump in, any of the speakers, if you know of anything, but this does sound like a wonderful suggestion that if you go to developercommunity.visualstudio.com and you submit it, I'm sure it's going to get at least eight upvotes that I can see here, people upvoting this question, but I'm sure it's going to get a lot more. Any thoughts on this being considered, or maybe being already in the product and I don't know about it?
I think I would upvote that too. I think it's actually a very good suggestion. So I think your recommendation to actually go there and have basically recommend and get the votes, I think it's the best, because it will help with the feature basically getting planned. And
so
cool.
Just a couple 2 cents if you need to sort of try and deal with a problem that has a relation to this now. On a sample basis, you can use xperf to get access to the PMU events for most of the hardware we support. For cache misses, the data is not as good as you might want because it's sample based. The challenge we always have in this space is that the PMU, the performance monitoring units for the CPUs, are different between vendors, so there's a lot of sort of support cost here. But I think it's a great suggestion, especially as processors get deeper and more complex. Having this kind of information to help people tune their application is useful.
Wonderful, thank you. We talked about code spaces, and there's a question over here on will non-Visual Studio compilers, build tools, and package managers also be supported in code spaces?
I can take that. The answer is yes. Actually, we are working, and you actually I recommend you, if you didn't already, please join the private preview. It's very simple. Go to /ms/VS Futures plural -sign up and record there your desire to test IntelliCode or code spaces in a private preview environment. You have that option. Please go there, do that. That will basically give you an early insight of what we do. It's very exciting. Is basically moving our entire experience into a new age of code spaces. Very exciting. And on top of that, the answer is yes. We are actually doing all of that because the experience will, not that I'm actually giving you a peek, but it's true. You will actually use your local Visual Studio. The plan is to use your local Visual Studio as is today. But the entire basically work is happening remote, and it will be actually kind of exciting because from there the possibilities are endless. You have the access to that large virtual kind of computer that we can have there that can scale up and down and give you extra compute and so on. So just join that and you'll get a lot of information. There was also a very good demo done in an earlier talk. I recommend you checking it as well. Nick and Erica had modern C++. They show a little bit of code space there too. So it's actually
cool. Yeah, so I accidentally clicked delete on the wrong question because it jumped at me exactly as I was removing this question from the rooster. There was a question about whether we plan more work with clang-tidy real-time analysis inside the Visual Studio. Really quickly, I think we touched on this before. We do have support for both our code analysis and clang-tidy inside Visual Studio. By default, if you're building with the MSVC compiler, you're going to get our code analysis. If you're building with Clang, you're going to get clang-tidy, but you can also turn on clang-tidy for MSVC compiler. That flexibility is there. There's a blog post, again, on the aka.ms/cpp, as I was mentioning earlier, that goes into more detail. If the question was about additional support, hit us on Twitter and clarify what else would you like to see there. We'd love to understand, and this is an area that we're actively looking for feedback from customers.
It was touching the real time of it. I think we touched a little bit on when we mentioned linters. When you think about static analysis, it's an expensive operation, requires building. If you really want to build an entire code flow graph, you actually need to build. What we have IntelliSense. We added support for lints. If you play with 16.6, you have that support in preview channel. You can see what I'm referring to. Basically, we have quick access that will fill the gap from a productivity perspective before the entire static analysis build machinery that runs in the background can start give you also rich static analysis refactors available and basically highlight all the issue discovers in your code base. So from a real-time perspective, the same is true also for clang-tidy. We are working actually to benefit both experiences from the same thing.
So I'm starting to realize that we're probably not going to be able to answer all these great questions. We only have a few more minutes until the end. Bogdan, there is a question here about whether you can paste in the URL for the sign up for code spaces as an announcement on this chat.
Yes,
I think that would be great. While I ask Uzi for this question, which is, should we expect any breaking changes in VS 16.7, either C++ frontend or STL?
Is that a trick question? No, nothing big that we plan. As you know, if you've been keeping up with our releases in the last, I don't know, 2 or 3 years, we have been making deliberate changes that are breaking to the sources in order to catch up with the C++ standards conformance. And it's necessary as the compiler has been allowing inaccurate code to be compiled for the longest time, and we needed to way around it in order to move forward and modernize the compiler. And one of the biggest examples for that is, as we enable two-phase name lookup in our compiler, A lot of existing code that used to compile didn't compile, and a lot of existing code didn't compile, started compiling, right? So all of these are documented well. We have a lot of pages in the docs, Microsoft.com, explaining, if you see this error, it's likely that that you're running into this intentional change. And we try to make all of these break-in changes under a specific switch or mode that is not on by default. For example, permissive minus is a mode that we have been doing active development in making the compiler more strict to the C++ rules and the conformance, so that you can write C++ code that can be compiled and retargeted to different platform as a cross-platform source. So as well as the standard mode switches, we have C++ 14 stud colon C++ 14, stud colon C++ 17, and obviously there's going to be stud colon C++ 20 when we're done. We also have the C++ latest switch, where we make break-in changes that's dictated by the standards conformance itself. Back to, this was a quick backdrop. Back to the question itself. No, there is no deliberate change we're making in 16.7 in the library and the compiler.
All right, thank you. So we only have.
Maybe I just want to add up one thing. I added a link. Basically, in the link, you will see two things. One, it's code spaces. The other one is IntelliCode. IntelliCode is basically enhancements on top of IntelliSense. You can sign up for both of them. IntelliSense will benefit from machine learning, so you will basically guess what you want to code next, and it's kind of fascinating as well. So I give you a shout out to basically try to do that too. So it's kind of exciting.
I will take a really quick round on some of the questions that are here, and I'm not going to do justice to the answers, but here it goes, and you can follow up with us on Twitter. Will C++ support ever come to Visual Studio on Mac OS X? There is a top suggestion. Please go upvoted. We do not have immediate plans to add support for Mac. Please use Visual Studio Code. That is where the full C++ experience for editing, building, and debugging is being developed. Can you offer a few examples of at Microsoft, where Microsoft is using C++ internally or in its own applications and services? This is a great question. Russell is our resident expert. He's working with a lot of teams across Microsoft. Can you throw in a few names really quickly?
Yeah, so the list is long.
Of course.
And varied. The sort of things that are top of mind for me is most recently during the shutdown, we actually engaged with a team to help deal with the cloud workload for Teams. So the low-level components that deal with video and audio streaming that you're actually using today are examples of things that are written with C++ and used internally. This sort of like this pattern of sort of like the high-performance pieces internally tend to be written in C++, and this team helps optimize them to make sure that you guys get the best experience.
Yeah, I would add that is a lot of products that right, are built on that. Like from Windows Office, there are a lot of significant components in there. Many of the games that you play on Xbox and all that, they are built on top.
Visual Studio itself.
Pieces of Visual Studio is right. VS Code, a bunch of pieces in VS Code. The ones at least ours are built with C++. So it's present everywhere where high performance is needed, basically.
The other question is, are there any plans for Rust support in Visual Studio? And the answer is we listen to our customers. Go submit a suggestion. We will consider it. There are no formal plans today to add support inside Visual Studio, but Visual Studio Code has an extension for Rust, and I hear it's pretty good. So go give it a try and let the maintainer know how's it going. What changes support will be added for WinUI 3 support in C++? Definitely go check out the Windows blog post that just went live. Check out the repo where WinUI 3 lives. There is support for C++. They have new templates for C++ that you can get started with. So definitely give it a try and send us your feedback. What is the best way to use WPF with C++? This is a longer question. Hit us on Twitter and we'll try to get the answer to you. Do you plan to support Conan like vcpkg? I think Uzi touched on how we're thinking about vcpkg. We did not talk about integrating Conan and supporting it. We are open, just like with Rust, to have a conversation about what are the best tools and how we can make Visual Studio to be the best tool for the job. So do submit your suggestions, do submit your votes. This is very useful for us to gauge what level of support do we need to support. With that, I can see a lot more questions here, and we will follow up on that. Hit us on Twitter. Let me bring up really quickly the slide again with our Twitter handles. And with that, I'm going to say thank you for everyone that joined us. I think we had some very great questions from you. We love this conversation, so let's keep it going. But this one in particular needs to stop now. All right, so bye, everybody.
Okay, thank you all. Bye.
Bye all. Thank you.
Thank you.